Find the volume of a solid made by rotating the area under e to the x over the interval 0 to ln 4 around the x-axis. Okay. So just to, if you can, it's always a good idea to draw a little bit of a picture of what's going on. So e to the x looks a little something like that. We are going from 0 to ln 4. We want the area here. So nice and neat up against the x-axis there. And we're just going to take this area and we are going to rotate it around the x-axis. And we know how to deal with this. Okay, we get sort of circles as we go around. And the radii of our circles are just the height that we get from the function. Okay, so pi r squared is our cross-section circle. And so the volume, we learned the formula for this. Okay, we integrate over the same range of the x-axis, so 0 to ln 4. Then pi r squared, so pi, and then what's standing in for our radius? The function itself. And once we've got this set up, we don't care that it's a volume question. Okay? It's now just answer this definite integral. So one thing you can do is take the pi out right away. Okay, I find a lot of people do that. No sense in having the pi in there. It usually doesn't combine with anything. Now, the e to the x squared, there's something we can do. Okay, we can use our exponent rules to combine that. Okay. And now, well, maybe we need a substitution. It's entirely possible. Maybe we want to rearrange this a little bit more. I mean, one thing you can do is write this as e squared to the x, and then it's just your garden variety exponential function. Just the base is e squared, which is, what, about 8 something or other? Okay, so you can absolutely do that approach, or as I say, you can reverse chain rule this, so use a substitution. Whatever you want. I think just because it's so rarely seen, I think I'm going to use this approach. Okay, so I'm going to rewrite it a step more. I mean, there's so many questions out there that use substitution, and not that many that rely on a clever exponent rewrite. Okay, so what's my antiderivative going to be? Okay, we will have the same exponential function divided by ln of the base. Okay, but ln of e squared, ln and e to the cancel out. Okay, so either way you do it, you'll get e to the 2x over 2. Okay, so, you want to do a substitution, go right ahead. So we're still finding our volume. We've got, now we need to plug in, what was it, ln 4 and 0. So e to the 2 ln 4, and pi e to the 2 times 0. Okay, what can we do here? Well, 2 ln 4, we could bring the 2 up there and say it's going to be e ln 4 to the power of 2, or ln 16. 2 times 0 is going to be 0. And e to the ln, once again we can see we're canceling out a little bit, it's just going to be 16. And e to the 0 is just 1. So we've got 16 pi by 2's minus 1 pi by 2. Our answer here is going to be 15 pi by 2. We'll make that 5 look a little more convincing, shall we? 15 pi by 2 is the volume of that solid. Okay, so we'll go over the main beats. We had to set up our formula from volume, and then we just had to integrate. And you could use a substitution, or I chose to go the road less traveled and realize it's just an exponential function in disguise. And then we just plug in and get our answer here.